Hello guys, here's the next second example where we're given a problem where they're only asking us to find the angle and the angular speed. There's no given forces, no given mass, not asking for energy, not asking friction laws. So it's gotta be a kinemaxic problem, and we know it's a rigid body. So we wanted to identify what's going on in this problem where if you realize how it translates, there is no rotation from this picture we're seeing, so we can assume that this problem is pure translating. And another thing is that we want to analyze from point C to D rather than point B to A, only because we're not given the angle directly. So it's best if we do from D to C. And because it's per translating, we know they're moving in sync. It's moving in sync. The bar, the person, the linkage are all moving in sync. So we could say VB is the same thing as VP, VN, VC. After that, we want to analyze from the linkage from C to, from C to from D to C, only because if we set our reference point at D, since there's a pin, there's not really gonna be moving. Therefore, we could say it would just be a lot more easier if we did that. And we were our governing equation. Since we let VD be the reference point and it's pendant, we let that equal to 0. We know how from pin C B to C is just an angle because it's translating at a curvilinear motion. So from there it's going to be moving in an angle, and since it's moving to the left, it's going to be negative. And then when we take the cross product of K cross I, we're going to get J, but it's negative because of the minus sign, and K cross J is negative I. And once we're given everything else, another thing that we want to say is write down everything we give, simplify it, and we're given this. And as we approach, we know VC is equal to VP only because they're all moving in sync and pure translating. It's not rotating or anything like that. So from there, we can substitute our values that we obtained earlier, and then we gather all our I hats and J hats and write it in the form of system equations. And we're asked to find the angle. And if we divided it, it simplifies everything else. So if we divide from equation 2 to 1, we're gonna get the tangent of phi. And if we take the arctangent of solving for theta, we're gonna end up with 33. And from there, we could choose any of these and plug it and solve for VDC, and we would have got the same answer regardless of which one we choose. And we obtain these. And since it's moving in the since it's in the has a minus sign,